Perfect. So everything okay? All's good? Okay. So let's get into Canvas. And in typical, I have kind of things outlined here in Canvas, and I have it linked to a Google Doc, which is right here, and you can open that up. It's called the NLP ML assignment. Now, can you guys say NLP? Good. Okay, you're done. All right, good. NLP stands for Natural Language Processing. Can you guys say Natural Language Processing? Yeah, you guys are going to have an experience with that this evening, and then we're going to use that on Thursday, when we're going to explore that even further. And you're going to be blown away at how important NLP has emerged, has become. Now, historically, this assignment is built in two pieces. And I devised this during the COVID period. And what the COVID people had to do is they had to do this assignment from home. So they actually had to read the document and do the assignment. And I didn't used to do anything with the students. Just the way that I learned is the faculty go out, kill it, have a hard time. Have a difficult time with this assignment. Bye. And so the students would gather together, and they would survive together. And so I would give out these very elaborate documents, these 20-page documents of like, here's what you do next, and da-da-da-da. And so now I'm trying to get past that and just do this stuff with the students. So you'll notice the right side is for people where if you don't want to do the hands-on portion, do this side. And so occasionally there's, 0.25% of the students don't want to do the hands-on portion. The hands-on portion takes like 10 minutes, but they just don't like to work with technology. And that's not a problem. They would prefer to do 10 hours of research than 10 minutes with technology. That's really quite okay. We need people to do research. And they're intellectual people. They tend to be from marketing, and they tend to say, well, I'm not very good with technology. And that the number of people like that are disappearing. Something happened during the pandemic. Everybody got dialed into technology. So I don't have that, bright and talkative young marketing student who comes in and says, oh, by the way, I'm not very technical. I just don't have that person right now. I used to have them in spades. So be like, oh, that's okay. Let's talk about technology. That's okay. Nowadays, everybody is, quite okay to interact with the systems. So the left side pertains to you. And so where we go is we press this link, and it takes us to Amazon. And so go ahead and follow that link. It's actually a tutorial that uses a natural language processing utility inside of Amazon Web Services called Amazon Comprehend. Can you guys say Amazon Comprehend? This would be a good resume builder. Oh, we got to do that resume. Oh, you got to get me to. We'll do the resume maybe Thursday. Procrastinate. Why do what you can do today when you can do it tomorrow? If you don't want to do it, you don't want to work hard, put it off. If you don't want to work hard, just put it off. But that would be a fun resume for you to do Amazon Comprehend in your resume. So let's follow that link. And that implies that you need to log in. And so go ahead and sign in. And I'll let you take a moment to do that. And give me. Okay, so here's the link that you followed, Analyze Insights in Text. And the way that Amazon Web Services works is they usually supply a lot of tutorials. And the tutorial system in Amazon Web Services has gotten quite good. And I think what's odd is that the Amazon Web Service is now the dominant technology in information systems. And I know that when I travel the hallways of my discipline, I hear the only technology I hear people talking about is AWS. And that's interesting. When it was 2014 and 15, I was beginning teaching at Cal State. I was heavily involved with startups, and every one that I would get involved with, and every couple of years would be a big new investment in Amazon Web Services. So I'd just gone into a couple of companies, and AWS is just the de facto tools for startups. And so in 2014, I was, teaching a couple hours a week here, and very involved with these companies. And I would always bring that experience into the hallways, and I would run into people like Dr. Pike and other the professors here, and I'd say, hey, I think just Amazon is just coming to eat our lunch. I think it's just going to be a big deal. And that really the word back then was like, well, we want to create our own clouds, we want to create our own software-defined networks, we want to create our own infrastructure, And it's interesting now that Amazon has really become the dominant way of doing IT. It's just a very interesting, it was very obvious, back, 8 years ago. So when you're doing an Amazon system, there are so many branded systems within Amazon that, you look at the bevy of services here, there's always going to be tutorials that accompany the Amazon. So if you can outline, if you can lay out 2 or 3 hours, you can usually learn the technology because they have so many learning resources on Amazon. So this is an example. So this is Amazon Comprehend. So we go down into the lab, get into your Amazon, and then go to the Amazon Comprehend Management Console. So go ahead and let's follow that. And you're logged in. You can see your username. And we can go ahead and launch Amazon Comprehend. So what they do is they actually begin Comprehend. And I'll sit still. I'll let you catch up. Now, when they launch Comprehend, they give you a little bit of sample text. And the example is a little bit nonsensical, but it contains the kind of statements that Comprehend is looking for. So say this is an email that somebody sent you, and it contains, hello, I am, this is my name, your company, da-da-da-da, and your credit card account, da-da-da-da, has a minimum payment, da-da, that is due by July 31st. Okay, so you and I understand immediately what's going on, the context. Now, human beings are extremely good at identifying the significance of things extremely fast and connecting one experience with many, many other occurrences of other experiences. So our ability to remember and then apply memory to a situation is very good. And that's what humans have always been able to do. Computers, on the other hand, are not good at identifying similar things and then looking at past occurrences in the same way that people do. Computers need to be specially designed to have that kind of memory recall, where it sees something and then it sees other patterns like it. That is a major project amongst artificial intelligence designers. And frankly, they need to create file systems that are amenable to that kind of retrieval. And then they have to create databases of things that resemble something. So when it sees a motorcycle, it knows it's a motorcycle. Or it sees the word, hi, I'm John. It needs to have other instances of language that it can learn from. And what we need to do as human beings is say, Google, that is a motorcycle. Or Tesla, that is a motorcycle. Or Amazon, that is a name. And so the more that we can tag instances, the more we can teach systems to remember things properly. But that is not built into computers. Computers are very good at storing large volumes of data and then looking at that data row by row. They are very good at that. So things like statistics, big data, that's great for computers. Computers are good at that. People are bad at doing that. So the IRS is a big computer. That's a good role. Collecting everybody's income tax and calculating refunds, computers good, humans bad. Human beings, knowing 150 people and knowing all the details of 150 people on a football team. That's what the human beings are very good at. And what human beings are also very good at is looking at something and saying, that reminds me of these other things. Maybe this thing is like these other things. And that kind of quick similitude is very endemic to the neural architecture of human brains. So what we have here is we have some language, And we have instances where computers are crossing the line and they're beginning to think like people, where it sees a letter and says, that looks like, and so you understand the sentence here. It says, that sentence looks like, that looks like a name, that looks like a name, that looks like a company, that looks like an account number, that looks like money, that looks like a date. That's another undefined important piece of personally identifiable information. That looks like an address, and that looks like an email. So it has been taught over time to recognize similitude between things and say that thing is a piece of personally identifiable information. So PII, personally identifiable information, personally identifiable information. And so it identifies things that resemble. It has a 99% rate of confidence interval in recognizing these things. So it means that, is this a positive letter? Well, the letter hasn't actually been finished. The letter is not even a real letter. It's just a collection of phrases that it can identify. So is it a neutral letter? 50-50. Is it a positive letter? No, it's about 90% not positive probably. Is it negative? Well, it's maybe about 20% positive or suspicious that it's a letter that contains something challenging. Does that make sense? And then whether it's mixed, it has about a 0.14%. Now, the intent is, well, can we take blocks of text, like messages or comments left on message boards, or maybe somebody is speaking this over the phone, and as you're speaking it, the computer is transcribing the text and applying the NLP to what you're saying, like a customer service, like, hi, welcome to Southern California Edison. What would you like to do today? And you say, my power's out. Oh, it sounds like your power is out. Would you like to speak with a technical service person? Well, yes, I would. Thank you. What if you call up Southern California Edison and said, hi, what can we help you to do today? And you say, you know what? I'm so fed up with the fact that, I called here last week. I am so sick of calling and no one answers, and I'm just really frustrated right now. Then the system says, this sounds like a tough customer. Like, I can see that the sentiment here is definitely negative. Maybe I need to send this person to a customer service person with an elevated urgency notice. Like, hi, I'm the extra nice customer service person. What can I help? Like, thank goodness. Now, NLP-based systems want to have the ability to handle whatever the incoming business is. I find that if you guys call the Apple Store, that you will be conversing with a Siri-like NLP application for quite some time. Hi, this is Apple Store, Rancho Cucamonga. What can we help you with? I want to make an appointment for the Genius Bar, but okay, we can help you do that. Make an appointment for the Genius Bar. Does that make sense? And so NLP applications, I think you guys are interacting with a couple of them right now. There's probably a couple of them on your phone. There's definitely at the other end of, customer, phone, you call up the airlines or you call up, your credit card company. But usually we have people who are taking those calls, but it's only after the AI system has done everything that it can automatically, and then it hands off to the expensive hourly people in the Philippines. Does that make sense? So this is kind of where we're at right now. It can identify the facets of speech, hello, I am, verbs, pronouns. And so the comprehend service is really all about separating those critical facets of speech and then providing it back to you as an application developer. So if you can understand that this is what the underlying API or the underlying data looks like, what they're really giving us the opportunity to do is write an application that can actually consume the NLP output, and then maybe we could do something with it. We can reply, oh, would you like to make a payment for account number da-da-da-da? Or, hello, Zhang, oh, is your company any company of financial services? Or, maybe we can leverage that information somehow. Does that make sense? Now, in my mind, there's somewhat of a big question mark where, and the Harvard business people need to know this, is that just because we are working with artificial intelligence doesn't mean that we're winning. It just means that we're trying. It just means that there is some kind of ongoing effort, and there may be a direction that this thing is taking. So, for example, the Tesla autopilot thing, it's been, for the most part, a big success. So, I have friends who have recently purchased, $100 plus, $160 plus $1,000 Tesla vehicles. And I visit with them and I say, do you use the full self-driving? They're like, all the time. I haven't driven my car for months since I bought it. It just drives me to work. It drives me to, I go to Best Buy. It drives me to Best Buy. They're really remarkable cars. So, we're beginning to have these Modernas and these Teslas where there's been an AI effort over the years that's resulted in something really valuable. Now, this is a sad example, and this is Riverside, California, where, the Tesla right now is not in a process of recognizing motorcycles. And right now, it's actually having difficulty with motorcycles. And there's a series of fatalities, very worst case scenarios, where somebody is riding a motorcycle in front of a Tesla, and the Tesla's on autopilot, and the Tesla disregards the image of the biker. It can't dissect the image of the biker from the car in front of it. And so it doesn't understand motorcycles. And so the last class I was speaking with some of the students, and I said, have you ever had to explain to a child what a motorcycle was? And I had a parent say, well, I did. I was driving the other day, and then I had a motorcycle come into my lane, and I moved left, and my son asked me, why did I do that? And I said, well, you should let the motorcycle go by. He drives in your lane. And so I was thinking, well, we probably have never had to explain motorcycles to children because the children aren't driving our cars. Does that make sense? As a person, though, when you guys first learned to drive when you were 16, 15 and a half, did we have to explain to you the sanctity of human life? Did we have to explain to you how precious motorcyclists are and how precarious their position is? And the answer is, well, we probably didn't really have to do that because you guys are human beings. You see that there's a person on that motorcycle. So how do you explain to a piece of AI to respect human life, to respect that that's a motorcycle? Well, the answer is you have to show thousands, tens of thousands of different images of motorcycles to the Tesla AI system. And it takes photographs and you put boxes around things that it sees as distinct entities that are moving on its own pace. And then you have people that tag it. So they actually have a couple hundred people, I think 200 people at Tesla that actually look at Tesla footage and then they tag, that's a traffic light. That's a motorcycle. That's a cat. That's a person. That's a stop sign. And so the lexicon of the roadway has been explained to the Tesla many, many times over. But apparently, it doesn't yet understand motorcyclists. Does that make sense? So when we talk about AI, we're saying, well, people are very good at identifying things and the significance of that thing and attaching our understanding of that thing to other things. Like, that's a motorcycle. I understand that's a motorcycle. Motorcycle contains a person. And here's the problem. They go a little slower, and I need to keep more distance from it. So motorcyclists are in a uniquely dangerous position, right? And so, we need to get away from that person. Human beings make very quick associations. Computers can accumulate massive amounts of data, but they can't make those associations until we teach it what those associations are. So we're developing systems that are increasingly good at that. NLP is just an example of teaching it to recognize things. And what we do is we employ people to do that. So when we look at artificially intelligent systems, these are computers that can amass large volumes of facts, images, language, and we are helping that thing to interpret different patterns. That thing is a motorcycle. That thing is a name. That thing is probably an account number. And so as it sees it in the future, it applies that training set. And so we're kind of in an era where that's becoming more and more natural normal. But where we are, and you guys should know this as business people, is that this is about as good as most. I mean, Tesla has its own systems. But where Azure and Google Compute Cloud and Amazon, what they're offering right now is these very raw machine learning services where it can offer the basic open source algorithms and people can download them and begin to use them inside of applications. But the difference here is that you need a programmer who can leverage that information and create rules and applications around it. So basically, a lot of AI right now is like the iPhone in 2008. It's here, it's working, it has some success stories. Steve Jobs can use it up on a stage. There's even people who own them. But by 2010, you had an app store. You had thousands of apps coming out. And if you want to make a video game, it would be good to make it on the iPhone. If you want to make a phone, an Instagram, we are AI is kind of an iPhone without an Instagram at this point. And so it was really 4 years. Really, it was 2011 before we began the Instagram process. By 2012, Instagram was bought for $100 million, on the eve of the Facebook IPO. So really, we are a couple of years away from kind of this startup frenzy, but we have all these building blocks. And so I wanted to put it out there. We're kind of in an interesting era, and I wanted to bring Spot into the picture. This is the Boston Dynamics Spot, and it's like a little $75,000 dynamic robot. And so I want to play this. I don't want to crash my own video player, but I'm actually recording this as a video. So perhaps I'm gonna show you guys this for the class. But if you're watching the video right now, perhaps you go ahead and Google the videos of Spot. And I'm going to show you guys Spot in a moment. But maybe consider this: we have a lot of robots that have gorgeous movement and gorgeous locomotion, and they can keep their balance. And we have gorgeous APIs on Amazon that can identify facets of text and understand text like a person. But we don't have a lot of, we have a lot of intelligence, but we don't have a lot of humans. We don't really have a lot of actors that are doing interesting usages of the technology just yet. And there's very few instances. There is the Moderna, right, where you have AI that is set that that's doing drug discovery or genomic research, and then we have Teslas that are doing that are recognizing traffic, and Moderna has some flaws in drugs they've made, and Tesla has some flaws in cars they've made. So these are the first real businesses that are made on top of these AI platforms. So Silicon Valley is saying, look, there is a lot of potential for new businesses to be made on top of this AI. For example, an airline that is run with AI, so that is optimized for all the complexities. Or we have a FedEx, a logistics business that is optimized for AI. Maybe an Amazon that will build an AI that will self-optimize. Does that make sense? Or we have this notion of, the Chinese government doing, massive surveillance on its citizens in order to, have social order, to put it kindly, where people cross the street incorrectly and then they are in fear of social debiting, social credit being decreased. So we have a few very large scale examples out there. So we have the business people who are saying, well, AI is the basis for new industries. But frequently the Harvard business people are not the ones actually producing those applications. It's the hardworking people elsewhere who are going to have to produce them. But you're on an interesting cusp. So let me just wrap up my video here and invite you all to